Hey guys, we're still in chapter 8 and we're looking at section 8.8, which is writing linear equations. So our vocabulary is pretty straightforward, pretty simple. It's really an equation that we're going to discuss. So let me just remind you what we talked about last time. Last time we were together, we talked about the slope-intercept form of the line, right? So let me kind of make a little thought bubble up here. And we remember slope-intercept form of the line was y equals mx plus b. We saw how useful it was because m is the slope when we have an equation in that form, and b is the y-intercept, right? So we have, there we go. We have all of that. Now we've got this form of a line, which is called point slope. So what this line says is if you're given some point, x sub 1, y sub 1, right? The sub 1 just kind of defines it as a different value than some other x or some other y. So if you have some specific x and y value and you know that the slope is m, then you can create the line instantly. You can write the equation of that line by simply putting the slope right here and taking y minus whatever the y term is here is equal to the slope times x minus this x term here. So let me do a quick example. So what if I told you that there was some line that ran through the point 2, 3 and had a slope of 7/5? Okay, totally probable, right? So what I would do is I'd take this form, y minus y sub 1 equals m times x minus x sub 1. And what I'm going to do is I'm literally going to go and erase the things that I'm about to put in. So what I would do is replace 2, since this is the x term, would go here. 3, since this is the y term of that point, goes there. And my slope 7/5 goes here. And I have now very quickly, with that form of a line, with this point slope form, created the equation of a line. So that's why it's so helpful and that's why it's so neat. So that's what we're going to talk about and use today. So let's look at our first example. It says write an equation of a line in slope-intercept form for both of these sections. So the first one, we're in slope-intercept form. So we remember slope-intercept form is our y equals mx plus b, because we're given the slope and the y-intercept, so that's slope-intercept form. And this is pretty easy, right? Because we take that form, y equals mx plus b, rock out with our eraser, erase that because we're going to replace it with the slope. And then we're going to erase this guy because we're going to replace it with the y-intercept. And I'm going to also erase that sign and make it a minus 5. And I've done it. Literally that simple, okay? Let's see if we can do the same thing here. Again, we're looking for slope-intercept, so we're thinking of this equation, not the new one that we just learned. And so what I need is the y-intercept and I need the slope. So the slope I know I get from rise over run, and my y-intercept I get from observing where the graph actually hits the y-axis. So it hits the y-axis at a positive 4, so that's my y-intercept. And the slope, well, I'm going to think, how do I get from this point to this point? I would have to go down 1, 2. Let me use a black pen so you can see a little bit better. I'd go down 1, 2. So that's negative 2. Change that back. So that's negative 2 over, so that's my rise. My rise is actually negative the way I'm looking at it, over my run, which is 1, 2, 3, 4, and 5. So I'm going to write that as a positive 5. So my slope is negative 2 over 5. Had I chosen to do it the opposite way, had I started with this point and thought about which way I'd go, I'd have to go up to 1, 2, and then left 5. So I'd have instead, right, we kind of talked about this in the last video when I made a mistake. We have 2 over negative 5, right, which is a negative slope, and negative 2 over 5, which is also a negative slope. Make sense? All right, so with that in mind, what we're going to do is just write this equation down. So for this problem, for this graph, we know that y equals m being negative 2/5, x plus b in this case being positive 4. And I've got my answer. Not too bad, right? Pretty simple. Let's take a look at our next example. So here we're going to write an equation given 2 points. Write an equation for the line that passes through these 2 points. Now, we were not told in this particular example which one to use. So we still, which one in terms of the forms of a line that we can use. So we have a choice. We could use y equals mx plus b. And we could also use point slope form, which is y minus y1 is equal to m times the quantity of x minus x1. I'm going to do this example twice so we can see it in both ways and kind of see the connection between the two, just because I know you want to know. You just want to know. You're so interested in learning. I love it. So the first thing we need to do to put it in this slope-intercept form, which we all have come to know and love, is we need to figure out the slope. And we know that slope is the change in y over change in x. So the first thing I'm going to do is calculate the slope. My slope is change in y over change in x, therefore I'm going to say 8 minus 5. So I'm going y minus y sub 2 minus y sub 1, if you'd like, over x sub 2 minus x sub 1. Notice I'm maintaining the same order or the same pathway in terms of what which point I'm using first. So 8 minus 5 is going to be 3, and then 4 minus a minus 2 is actually a positive 6. So I see that my slope here is 1/2. So that's part of the battle. But how do I find the y-intercept? Now that's a little bit more tricky. So here's what I'll do. I'm going to shrink this, move it away a little bit so I have a little bit more space, and make it smaller and think about what I need to do. So now what I've got the slope. I know my situation is y equals mx plus b. I've got my slope. So what I'm going to do is I'm going to replace this m with the slope. Still looking for b. I get that. But I'm going to first start by doing that. Now the thing I'm going to do is I have the power to use either one of these points, because both of these points have to satisfy this equation. I can use either one of these points in for x and y, and then my last variable would be b, and I could naturally solve for b. So it doesn't matter the point that I use. I like using any point that feels good. I'm going to use 4 and 8 just because it's coming first, and I'm going to do what I can do. I'm going to plug in 8 is equal to 1/2 the x term, which is 4 plus b. So now I have one variable, so that variable is what I was looking for, which is the y-intercept. And so now when I get that y-intercept, I've got the equation of the line. So 8 is equal to 1/2 of 4 is 2 plus b, and I can do a little bitty easy math. Let me see if I can slide this up so you can see good. So I can do that, and I find out that b is equal to a positive 6. So I've got the 2 bits of information that I need. I need the slope up here, and I need the y-intercept, and that tells me that my equation is y equals 1/2 x plus 6. I hope that wasn't too bad. Let's talk about what we did again really quickly. We first took the 2 points, we found the slope. After finding the slope, we use the slope and one of the points, either one would do, to plug back into the equation, so our only variable left was b. Then we solved for b, we got the x and y intercept, and we went back and wrote the generic equation for a line that passes through these 2 points, and we happen to know the slope and the y-intercept, okay? Let's see how we would have done that if we used this handy-dandy formula. So again, we would need the slope. Fortunately, we already found it over here, so I'm not going to go through that again. So we could start off with that. Y minus y sub 1 equals m, well, m is 1/2, times x minus x sub 1. Again, we just found the slope using these 2 points. No need to do it again. And the very end of this is simply to take 4 and 8 or -2 and 5 and plug it in for x and y, and then we're actually done. That's why this is a neat formula, though most people don't like it very much because it's just not what we're used to. So what is the y term here? It's going to be 5. I'm going to use this point, by the way, just to be different. Y minus 5 is equal to 1/2 x minus a -2, which is plus 2. And I can actually stop here, and both of these equations are exactly the same. And I know it feels uncomfortable, right? Because it's like, they're not the same. They can't be. So you could honestly stop here. You would get 2 different equations. And the only reason why 2 different looking equations, the only reason we can stop here is because it doesn't tell us to write it in a particular form. So when you're not asked to write it in a particular form, you can choose the form. But let's say you wanted to make sure that these 2 are the same. So what I'm going to do is I'm actually going to just keep pushing. Y is equal to y minus 5 is equal to, I'm going to distribute this, 1/2 x plus 1/2 times 2 is just 1. The next thing I'm going to do, you see it, I know you're smiling. I'm going to add 5 to both sides, and voila, I get exactly the same thing. Y is equal to, this has gone away, y is equal to 1/2 x plus 6. I told you they were equal. I told you. So anyway, you see that this moves very quickly. This is a really powerful equation. This is somehow comforting to most students. Most students generally try to hang out with the slope-intercept form. But I'm letting you know, if you don't have to, if you're not told which way to do it, you don't have to do it any certain way. All right. We have some other things to do. It says write an equation for from the table. So this table gives us some points: 0, 2, 2, 6, 4, 10, and 6, 14. Assuming this is a linear equation because we're dealing with the linear section. Let's test it out really quick. The jumps here, let me use a pen with color. From here to here is 2, from here to here is 2, and from here to here is 2, from here to here is 4, from here to here is 4, from here to here is 4. And what I'm seeing is that the rate of change is consistent. So I know for a fact that this is referring to a linear equation, okay? So now that I have that down, I can take any 2 points that I like and start working on them as I did with the last problem. If you hear my kids, I don't know why they are so loud. They're playing video games downstairs and they are the loudest ever. Let me see if I can shush them. One moment. That's better. Okie dokie. So I'm just taking 2 points, 0, 2, and 4, 10, and we're going to see what we can do, right? Let's go ahead. So what we can do is I'm going to rock out with y equals mx plus b. I'm going to first find the slope, and then I'm going to find the y-intercept, and I'm going to use my equation like that. So my slope is going to be find the difference in the y's. The difference in the y's would be 10 minus 2 over 4 minus 0. And that's going to give me 8 over 4, which is 2. So I then put my 2 directly in my equation, and I'm going to choose which one of these numbers to use, which one of the, not numbers, but ordered pairs I can use. And I can use any of the ones here, to be quite honest, right? Let's try this guy. So if I do this one, I'm going to put a 0 in for x. My kids are getting loud again. 0 in for x, and see how that works out there. So I put a 0 in for x and a 2 in for y, and when I do that, I get 2 times 0 is 0 plus b. B is equal to 2. And you know what? This isn't that shocking. When x is 0, let me use a colored pen. When x is 0, y is 2. And if that's the case, that's definition of what the y-intercept is. So the y-intercept was actually given to us. We didn't have to do all that work, but that's okay. B is equal to 2, and my equation is, let me write it down, y is equal to 2x plus, because that's my x-intercept, 2x plus 2. So that is my equation. And again, since we weren't defining a particular way that we had to do this, we could have also used the point slope form. Cool? I hope this is making sense. Let's look at our final example. So our last example, example 4, write an equation and make a prediction. So the boiling point of water at sea level or at an altitude of 0 feet is 212 degrees Fahrenheit. The boiling point decreases 1 degree Fahrenheit for every 540-foot increase in altitude. Estimate the boiling point for an altitude of 4,000 feet. Okay, so I got to talk this out a little bit quickly. The point is we're going to use y equals mx plus b, and we're going to look at these as points. Altitude 0, 212 boiling point. Altitude 540, we're going to go down 1 to 211. So technically these are 2 ordered pairs or 2 points that we can use to find the equation of a line. The beautiful thing about this, the reason why I've chosen to use y equals mx plus b form is because we're given b. When x is 0, y is the y-intercept. So when the altitude is 0, 212 is our y-intercept. So my equation is going to be the slope times x plus 212. What's the slope? Change in y. I'm going down 1, but I'm going up 504. So that's 540, pardon me. So that's negative 1 over 540, and that's equal to y. So this is my equation. Y is equal to this. The next thing I'm going to do is replace x with 4,000. And so when I do that, multiplying these guys together, we get negative 7.407 approximately. It's actually 407 repeating a whole bunch of times. Then we're going to add that to 212, and then we get that y in this particular case equals 200, and I have my answer down here. What was it? 204.59. Let's say 204.6 degrees to actually boil. That's the boiling point. All right, thank you for listening. I hope that made sense. Let's talk again if you want to try some more examples with the point slope form. Have a great day. Bye-bye.